To all, our topic is manufacture of glass. The manufacturing of glass involves the following steps. Mainly, the first step is the formation of batch material. Second step is the melting process. Third step involves the shaping. Fourth is annealing, and last but not the least is the finishing. We will study all the steps one by one. Let us start with the first step, that is the formation of the batch material. The lumps of ingredients which are used as raw materials are together known as the batch. These ingredients are crushed to a coarse powder. The ingredients are then obtained in a proper particle size, uniform in nature. The required quantities of different ingredients are separately weighed, and then they are mixed uniformly in the form of coarse powder in the required ratio. This mixture of powder ingredients or raw materials is called as the batch material. Different batch materials are prepared for different types of glass. Batch materials for some typical glass are as follows. For example, if we want to prepare a colored bottle glass, we need sand uh, equivalent to 1000 parts. We need soda, that is sodium carbonate, 360 to 375 parts. We need limestone, that is calcium carbonate, 175 to 240 parts, and dolomite, 0 to 20 parts. However, if again we need to prepare chemical glassware, then the batch will consist of different materials. It will contain sand equivalent to 1000 parts, hydrated alumina 180 parts, lime spar again 180 parts, potassium nitrate 30 parts, soda ash, that is sodium carbonate in 150 parts, magnesia 15 parts, and calcined borax 185 parts. In a similar manner, if you want to prepare window glass, the batch will differ and it will have sand, soda, and salt cake. Salt cake will be equivalent to 60 parts and coal 2 to 3 parts. In other words, we can say that depending upon the type of the glass that is to prepare, the batch will differ from one type of glass to another. The batch is now transferred either to the tank of a tank furnace or to the pots in a pot furnace. Now, these furnaces are used for melting purposes. Second step in the manufacture of glass is the melting process. Glass furnaces are of two types: pot furnaces or tank furnaces. The glass melt is produced from the batch material in either of the two furnaces, whether the pot furnace or in tank furnaces. Both these furnaces, whether the pot furnace or the tank furnace, they are of two types: regenerative type or recuperative type. Now, the purpose of regeneration is to utilize the heat of the waste gases for heating the incoming gases, and air is used for burning purpose. However, the regenerative furnace works in two cycles. It has two sets of jack work chambers and they are called as regenerators. The waste gases from the flame, after giving their heat in the furnace for melting, they go down through one set of regenerators. Now, these regenerators are chambers which are stacked with open brickwork or checkwork. The heat of the waste gases is removed in heating the checkwork to a temperature ranging between 650 degrees centigrade on the exit side to about 1400 degrees centigrade near the furnace. At the same time, air and gas are heated in a heated regenerator. The temperature which is thus attained is higher than the temperature of the flame from air and gas without heating them. The direction of the ingoing air and gas are reversed after every 25 to 30 minutes, during which one set of regenerators gets considerably cooled because of loss of heat to air and gas, and other sets of regenerators get heated up because of absorption of heat from the waste gases. Yes. As you can see in the figure, there are two types of furnaces shown. One is the pot furnace of the regenerative type. The figure 2 shows the tank furnace, and you can see the pathway of the air and the fuel gases. In the pot furnace, the air and fuel gases enter from the left hand side, and the waste gases exit from the right hand side. Similarly, in the tank furnace, they enter from one side and exit from the other side. Now, the object of regeneration or recapitulation is also the utilization of heat of the waste gases, and as a result, the utilization of heat of waste gases gives a higher temperature in the furnace. Now, in recuperation, the incoming gases flow only in one direction, and that too in a continuous manner. The hot gases pass through one set of passages while going to stack, and air passes through adjacent passage and gets heated before entering the furnace. Again, you can see in the figure two types of furnaces: the recuperator type on the left hand side and the regenerator on the right hand side. You can see the different pathways. In the regenerator type, you see waste gases entering from top, and again they are passing through the check work, and air and gas and exit out. Similarly, in the recuperator type, they enter from one side and exit from the other side. Much heat is saved by this regenerative principle, and a higher temperature is achieved. The burnt gases from the furnace, they are allowed to pass through one set of chambers which become highly heated up. Simultaneously, air being preheated by passing up the other previously regenerated chamber and is mixed with fuel gas burn. The flow of the gases in the air are reversed at every interval. In the tank furnace, batch materials are charged into one end of a large rectangular tank built of blocks. It also works on the regenerative principle of heat economy and is heated by the producer gases. In such types of furnaces, the walls serve to both to restrict and retain the heat and to hold the glass. Now, this was the part first of a lecture on manufacturing of glass. We will continue this lecture and finish it in the next class. Thank you.